You are moving right now. I don't mean you're walking or in a car or on a train. I mean you, the chair you're sitting in, the building around you, are all spinning on the surface of the Earth at over 1,000 miles per hour. At the same time, the Earth itself is hurtling around the sun at 67,000 miles per hour. And the entire solar system is being dragged around the center of our Milky Way galaxy at a staggering 500,000 miles per hour. That's a lot of motion, but it's all understandable, predictable, orbital. But there's another movement, one that dwarfs all the others. Our entire galaxy, along with thousands of our cosmic neighbors, is being violently pulled through intergalactic space at 1.4 million miles per hour towards something. Something massive, something mysterious, and something we can't even properly see. Astronomers call it the Great Attractor. The story of its discovery begins in the 1970s, not by looking out, but by looking back to the dawn of time. Scientists were creating the first detailed maps of the cosmic microwave background radiation, the faint afterglow of the Big Bang that fills all of space. They expected this ancient light to be almost perfectly uniform in all directions, a perfect echo of a young, smooth universe. But it wasn't. On one side of the sky, the microwave light was ever so slightly warmer, its wavelengths compressed and blue-shifted. On the opposite side, it was slightly cooler, its wavelengths stretched and redshifted. This wasn't a flaw in the universe's baby picture. It was evidence of our own motion. This dipole anisotropy, as it's called, was the first profound clue that our entire local group of galaxies was on a high-speed road trip through the cosmos, but nobody knew the destination. The hunt was on. A pull this strong had to come from an unbelievable concentration of mass. Astronomers pointed their telescopes in the direction of our motion, towards the constellations of Norma and Centaurus, expecting to find an unimaginably huge supercluster of galaxies, a beacon of light acting as the gravitational anchor. Instead, they found fog. They were staring directly into the plane of our own Milky Way galaxy. This region of the sky, known as the zone of avoidance, is so thick with our own galaxy's gas, dust, and countless stars that it acts like a celestial curtain, blocking our view of the deep universe behind it. The most significant structure in our cosmic neighborhood, the very thing defining our galaxy's ultimate trajectory, was hidden in plain sight, obscured by our own home. For decades, this cosmic mystery was like trying to understand a mountain by staring at the clouds covering its peak. But astronomers are persistent. They began using telescopes that could see in wavelengths other than visible light. Radio waves and infrared light can penetrate the galactic dust far more effectively. Slowly, painstakingly, they began to peer through the veil. What they found was the Norma cluster, a rich and massive collection of galaxies sitting right where the Great Attractor was predicted to be. For a moment, it seemed the mystery was solved. But when they did the math, the numbers didn't add up. The visible mass of the Norma cluster, even accounting for its dark matter halo, was only a fraction of what was needed to generate the colossal gravitational pull we were experiencing. It was a major part of the puzzle, but it wasn't the whole picture. The true answer was far grander and more complex than a single object. By mapping the motions of thousands of galaxies around us, astronomers realized we weren't just being pulled towards one cluster. We are part of something truly immense, the Laniakea supercluster. Imagine the universe not as empty space with galaxies sprinkled in it, but as a vast, invisible cosmic web of dark matter filaments. Galaxies are like beads of dew that have condensed along these filaments. Superclusters are the great intersections, the hubs where these filaments meet. Laniakea is our home supercluster, a sprawling structure containing 100,000 galaxies, and the Great Attractor region is its gravitational heart. It's not a single thing, but a broad, sprawling concentration of matter, including the Norma cluster and others, acting as the bottom of a huge gravity well that our entire section of the universe is flowing into. And the story gets even bigger. Further mapping revealed that even this massive structure is just one stop on a longer journey. Beyond the Great Attractor, at an even greater distance, lies the Shapley supercluster, a concentration of galaxies 4 times more massive than what we see in the Great Attractor region. It seems our Milky Way isn't just being pulled towards the great attractor. We are part of a vast, cosmic flow, a river of galaxies millions of light-years wide, streaming across the universe from a relatively empty region called the dipole repeller, past the great attractor, and ultimately towards the even greater gravitational basin of Shapley. The great attractor isn't our final destination. It's just the largest, most powerful eddy in the cosmic river we are currently navigating. And the vast majority of its mass, the true source of its pull, remains the invisible, undetectable scaffolding of dark matter. We may have charted the river, but the nature of the great, unseen ocean we are all flowing towards remains the ultimate cosmic mystery.